morning everybody. Well, here is morning right now that I'm recording this video. It's an honor to be with you in another video, in another lesson under the title of Polynomial Expressions, grade 10, and it is going to be the first section of chapter 2. So in this section we are going to talk about something that you may already hear about it or you maybe study it. Alright, so it depends on that system that you were in already. Alright, so here the first thing that we are going to talk about is these three things that we need to know them, we need to take care of them. Alright, like the first one is polynomial expression. Okay, what is polynomial expression? It is a mathematical expression, we can say, or it's a quantity that it consists of like numbers and variables in different parts. We call those parts terms, and they added or subtracted from each other. Alright, so clear definition from the book is here. It says that such quantities are called polynomial expression, which are the sum of simpler quantities known as terms. As I said, so there is a sum of like some parts, some simpler quantities that are called terms. Let's just come and identify terms. A term is an algebraic expression. Perfect. So it is an algebraic expression that results from multiplying a number by a variable such as 3x squared. So as you can see here, 3x squared. Let's just focus on this a little bit more. So red. Okay. So it says that 3x squared is a term because it is the result of multiplying a number. That number is called coefficient, and multiplying a number by a variable. Okay, the variable is x. So x squared here. Or it can be just a number. So whenever a term is just a number, in that case we call our term constant term. Alright. That is regarding to term. So we have got two types of term, algebraic term and constant term. Alright. The third thing that we need to take care of about it here is the degree, which is the main topic of the first, the beginning of the section. The main, actually point, the main matter. The degree of a term is the highest power of the variable in the term if there is only one variable. So when we have got a polynomial, and in our polynomial we have only one variable, in that case, in order to find out the degree, we are going to look for the highest exponent. Alright? So the highest exponent will in any term would become the degree of that polynomial. But if we have got a polynomial that it consists of a term or some terms that in each one of them we have got more than one variable, in that case it is the sum of the powers of the variables if there is more than one variable in that term. So in case we have different examples, just be patient, we will go through them. In case if we have more than one variable in one term, in that case we are not going to count on the highest exponent, but we will count on the sum of the exponent of those variables that we have in that term. Alright. There is something here, an illustration regarding to what we have done here. Okay, so here there is an algebraic, a polynomial that it is consists of two terms, 8x squared plus 1. That term is called algebraic term, algebraic expression, let's say, and that one is called constant term because it is just a number. Okay, so we call that number behind the variable. It has a specific name, special name, that it is called coefficient, and the variable is here. That is the exponent of the variable. Sorry, and the operator is addition. and then we have got a constant term as well. So let's go to the next slide and see what we have here. We have got something, a table that it is important since in your book it came, so we need to discuss about it. Okay, a polynomial with degree 0 is called constant. So whenever we have a constant term, its degree would be 0. That's it. And when we have got a linear function that you studied already in previous grade, which is 9th grade, a linear function has degree of 1. Quadratic function, you will study it here, and I'm pretty sure you studied like a part of it in grade 9, very, very short like introduction regarding the quadratic function. So their degree is 2. Whenever the degree of a polynomial is 2, so it's called quadratic expression or quadratic function. Okay. When the degree is 3, it's called cubic. When the degree is 4, it calls like quartic. Okay, quartic expression. So you need them. Sometimes it might become a question, a multiple question. Like they give you a polynomial, and they're gonna ask you what do we call that polynomial. So it can be a linear function, it can be a constant, it can be a cubic, quartic, or quadratic. Perfect. So there is a question here. What is the degree of those polynomials? This is the question that you are gonna see it like commonly and mostly in this part of the lesson. So the degree, we said that there are two situations regarding degrees. If there is only one variable, in that case, we are going to look for the highest degree. For example, here in the first one, part A, there is only x. So in that case, what is the highest exponent? 2. And here in part B, as you can see, so let me just write it down, degree here would be 2. Perfect. And in part B, we have got 2x cubed y2. That is a term that it consists of 2 variables. In those kind of polynomials, we said that the degree would be the sum of the exponent. So here the degree would be 3 plus 2, 5. That is the degree of this polynomial. Perfect. So if there is only one variable, the highest degree will decide. And if there is like more than one variable in one term of a polynomial expression, so the sum of those exponents will become the degree of our polynomial. Okay, the next thing that we have gotten here is the address of those questions that I wrote in here. What is the degree of this polynomial? The degree of A. How many variables do we have in A? Only one variable, which is x. I hope that it is clear. Let me just check it. Yes, everything is clear. Just a second. It's going to be better right now. Perfect. So in the first part, which is part A, we have got only one variable, which is x. So the highest exponent will decide. The highest exponent here we have got 4, 1 here, and 6 over there. So the highest exponent is what? 6. Therefore, the degree would be 6. Perfect. Degree is 6. It is 6. And how about here? Again, we have got one variable, so the degree would be 2. So the degree would be 2. And here, okay, there is a term which is negative 2x squared y squared. In that term, we have got 2 variables, so their exponent, the sum of their exponents, so 2 plus 2, 4. In that case, degree would be 4. How about the next one, part D? How many variables do we have? Variable, be careful. So we have got one variable, which is x. So the highest exponent, here the exponent is 2, here the exponent is 3, and here is 0. So the degree would be the highest one, which is 3. Degree is 3. And finally, in part E, we have got a term that in our term there are like 2 variables. So I will leave this one. You can just write it in the comment, or you can just test yourself by it. We have got a term that we have 2 variables in it. So x3, y3. So the degree would be question mark. I will leave it for you. Perfect. that was about the story of degree. Okay? Right now, the next topic in this lesson is about evaluating. How are we going to evaluate an expression? How are we going to do it? To evaluate a polynomial expression that you have already studied, like how to evaluate an expression recently in previous grades. Okay. To evaluate a polynomial expression for a given value, we should substitute the given value into the polynomial. So whenever it asks you to evaluate the given polynomial for the given value, you need to substitute that value into the whole expression. Instead of each variable, you need to put the given value. Perfect. For example, look at this example here. 1 over 8 x cubed plus 2x plus 1 for x equals to 4. So here x is given. It says x equals to 4. So instead of each x, I need to put 4. In that case, 1 over 8 is the coefficient. We cannot change it. Instead of x, I have 4 powered by 3 plus 2 times, there's times between them, 2 times 4 plus 1. Perfect. So 4 to the power of 3, it's equal to 64. For those who did not know this one, 4 powered by 3, there is a common mistake from the student. It said that it's equal to 12. No, it's not equal to 12. You cannot multiply the exponent by the base. But you should write it in this way. 4 powered by 3 equals to 4 times 4 times 4. So when you multiply 4 3 times by itself, you're going to get 64. So 1 over 8 times 64 plus 2 times 4, 8 plus 1. And then finally, 1 over 8 of 64. So it means 64 divided by 8. You will get 8 plus 8 plus 1. So finally you're going to get 17. Remember, 1 over 8 times 64 equals to 8. Either you can say there is a denominator of 1 here, so the multiplication of fractions, numerator times numerator, denominators times denominator. Then since it's divisible by 8, you will divide it. Perfect. So for evaluating, you should substitute the given value into that polynomial that it is given. So there is another question here regarding to evaluation. Evaluating a polynomial, x cubed plus 5x squared plus 2x minus 3 for x equals to 2. So 2 is given. Instead of each x, we need to put 2. In that case, 2 powered by 3 plus 5, 2 powered by 2 plus 2 times 2 minus 3. Instead of each x, I just substitute 2. Alright, so 2 powered by 3, 8. Plus 5 times, okay, first of all, the exponent, remember PEMDAS, 2 powered by 2, 4. 4 times 5, 20. Plus 2 times 2, 4 minus 3. So 8 plus 20, 28, plus 4, 32, minus 3, 29. And I hope that it is clear. Perfect. Evaluating is easy, I believe. Do we have any other question? Yes, there is another question regarding to evaluating polynomials. Not only one question, we have got 2 questions here in our lesson. Okay, negative x powered by 4 plus x cubed minus 50, where x is negative 3. Nothing, so it's not a big deal. Just come and substitute the given value into the expression. Instead of each x, I'm going to write negative 3. So there is a negative here, be careful. And instead of x, I have got negative 3 powered by 4 plus, instead of x, I have got negative 3 powered by 3 minus 50 itself. So here, be careful. Negative 3 powered by 4, negative 3 times negative 3 times negative 3 times negative 3. So negative times negative, positive. Negative times negative, positive. Positive times positive, positive. And 3 times 3, 9. 3 times 3, 9. 9 times 9, 81. So here you are going to get positive 81 plus negative 3 powered by 3. The power is odd, so the result would be negative minus 50. I hope that you stayed with me and understood what am I doing here. So negative times positive, negative. Negative what? 81. Again, positive times negative, negative 27. Minus 50. all the numbers are negative, so remember, add them, but still keep the negative sign. Alright? It's not like multiplication and multiplying the signs. No. When we have addition of some negative numbers, add them, but still keep the negative sign. So 81 plus 27 plus 50, if you go and check it, you're going to get 158. So negative 158. Perfect. That is the result of the first one. I would love to leave the second one for yourself, but let's just do it, okay? Let's just do it. I hope that before I do it, just pause the video and try to like solve it by yourself, then compare it with me, with my solution. Okay, so 3x4 plus 5x squared plus x plus 8, where x equals to 2. Easy peasy, lemon is sweet. Okay, 3 times x is 2. 2 powered by 4. It's better to put it inside a bracket in order to not confuse. Plus 5. Instead of x we have got 2 powered by 2 plus, instead of x we have 2 plus 8. Okay, so 2 powered by 4, remember we need to multiply 2 4 times by itself, it's equal to 16. Perfect. So 3 times 16. Let's make this one. Plus 2 powered by 2, 4. 4 times by 5, 20. Plus 2 and plus 8. So 3 times 16, 48. I'm just going to do it here. 48 plus. Let's just plus these 3. 2 plus 8, 10. 10 plus 20, 30. So 48 plus 30 is equal to 78. Okay, perfect. I hope that it is understandable for you guys. Let's just move to the next slide and see what we have. So the next one, okay, we have got a very important topic, adding and subtracting polynomials. How are we going to add and subtract the polynomials? Regarding to the previous years, you had it to something like this. In grade 7 it started, the idea, how to add the polynomials. So first of all, identify the like terms. What terms are like terms? Two terms are like terms if they have got the same variable and the variable have the same exponents. Perfect. And then add only the coefficient of the like terms. So you have no right to add the exponent or to add the variables. No. Add only the coefficient of the like terms. And like terms are those which have the same variables and the variables have the same exponent. So finally, after you finding out and adding them or subtracting them, remember the polynomials must be written in standard form. What is the standard form? From the highest degree, from the highest exponent to the lowest exponent. Okay. There is an example here. It says find the sum and write the result in standard form. There are two polynomials. They added to each other, so we need to find the result in standard form. Okay. Do we have any like term for x squared? Yes, we do. So 3x squared plus 1x squared, 3x squared plus 1x squared, it's equal to 4x squared. Because the coefficient of this one is 1. So add only the coefficient, 1 plus 3, 4. Don't change the variable of the exponent. Okay, negative 5x cubed. We don't have any x cubed over there, so just rewrite it and don't change anything. We have 2x here and we have got 5x here. So 2x plus 5x, 2x plus 5x will give us 7x. And finally the constant term, we have got 1 plus 7 is equal to 8. So right now let's write the result in standard form, which is from the highest degree to the lowest degree, or the highest exponent to the lowest exponent. So the highest exponent is negative 5x cubed, negative 5x cubed, and we have got x squared after that, so plus 4x squared, and then finally we have got 7x plus 7x and plus 8. That is going to be the result in standard form. Okay? Yes, everything is clear. Okay, that is regarding to addition. For subtraction, there is only one more extra note that we need to take care of it. Yes, identify the like terms, the same thing for addition. But after the identifying, it's better to multiply the negative by each term in the second bracket and turn the operation to addition. That is one way. Or you might tell me, teacher, it's better, it's easier for me to go with the negative. Like for example, consider the negative with each term in the second bracket. So it depends on you which way you want to choose. I guess this one is easier because dealing with addition is easier than dealing with subtraction. So the second term is multiply the negative by each term in the second one, in the second bracket, and turn the operation to addition. Okay. The next note is subtract only the coefficient of the like terms, as we already have it for addition. Add only the coefficient. So here subtract only the coefficient. And then the definition of like terms are those which have the same variable and this variable have the same exponent. And then finally, just like addition, we need to write the result in standard form from the highest exponent to the lowest exponent. Perfect. I believe we have got an example here. So let's just follow, by following those rules, those terms, those notes, let's just solve this one. First of all, identify the like terms. Yes, x4, we have x4 here, 6x3, 5x3, these are the like terms. 2x, we don't have any x4 here, so we don't have any friend for 2x2 as well. And we have got 5, we have 3 as constant terms. So we just identify the like terms. Then we need to change this negative to positive by multiplying this negative by each term inside the second bracket. So we write the first one. We write the first bracket, x4 plus 6x cubed plus 2x plus 5. That is the first bracket. Change this negative to positive by multiplying that negative to each term in the second one. So negative times positive, negative 2x squared. Negative times positive, negative 5x cubed. Negative times x4, negative x4. And negative times positive, negative 3. So it just changed everything to negative. So right now, we have got x4 plus negative x4. So x4 minus x4 basically. We are going to kill each other and 0 will be. So nothing in terms of x4. And we have got 6x cubed minus 5x cubed, 5x cubed. So 6 minus 5, only 1x cubed would remain. And then we have got 2x, no term for 2x, so 2x. And then we have got nothing regarding to negative 2x squared will stay the same, no friend for 2x for x squared. And then finally the constant term is 5 minus 3. 5 minus 3 is equal to 2. Perfect. So right now let's write the result in standard form. Do we have any x4? Nothing left in terms of x4, so 0. How about x3? Yes, we have got 1x3. And then we have got negative 2x squared, negative 2x squared. There was no friend for x squared to be added or subtracted. Then we have got 2x plus 2x. And then finally we have 2 plus 2. That is the result of this subtraction in standard form. And I hope that it is clear. If it is not, just repeat the video and try to listen carefully in order to understand. Perfect. Do we have any other examples? I'm pretty sure we have. Let's see. Adding and subtracting. Okay, we have got 3 examples here regarding to adding and subtracting. Okay, x3 plus 2x minus 2x4 plus 1, all plus the next one. So let's just identify the like terms. It's addition. You don't need to change any positive to negative or this kind of stuff. So we have x3, 2x3. So x3 plus 2x3, 3x3. 2x plus 5x, we have 7x. Negative 2x4 minus 4x4. Negative 2x4 minus 4x4. So add only the coefficient, but keep the negative sign. So minus 6x4. And the constant are 1 plus 3, 4. Is this in standard form? Absolutely not. So let's just write it in standard form. The highest degree is 4, so negative 6x4. And then we have got plus 3x cubed. Then we have got plus 7x and plus 4. This is the result in standard form. How about the next one, part B? We have got subtraction. So for that subtraction, the same thing, but we need to change this negative to positive. So rewrite the first one, 5x4 plus 3x squared minus 2x cubed plus 2 plus multiply that negative by each term inside the second one. Alright, negative times 4x squared, negative 4x squared, cube. Negative times negative, positive 2x2. Negative times positive, negative x4. Negative times positive, negative 3. Perfect. Right now add them. So 5x4 minus 4x, by the way, sorry. 5x4 minus 1x4, so it's equal to 4x4. Is that? Alright, 3x squared. Do we have any x squared here? Yes. 3x squared plus 2x squared, 5x squared. Plus 5x squared. And then we have got negative 2x3 and negative 4x3. Again, the same thing, negative 2x3 minus 4x3. So add the coefficients, minus 6x3. And then finally the constant term 2 minus 3 negative 1. The question is this result in standard form? No. So we need to write it in standard form. Okay, just come here. The highest exponent is 4x4, no problem with this one. But then x cubed comes first before like 5x squared. So minus 6x cubed plus 5x squared minus 1. Look, from the highest exponent to the lowest exponent, that is what we call standard form. Okay, and the last one, the last question, it's a short one. So there is a negative, change this negative to positive by multiplying this one to each of these two terms. So we write the first one, x squared plus 3x minus 1 all plus negative times 2, negative 2, negative times negative, positive 3x squared. So finally we are going to have x squared plus 3x squared, 4x squared. 3x, we don't have any x terms, so we write 3x. And then finally negative 1 plus negative 2, negative 3. Add the numbers but keep the negative sign. This is the story of adding and subtracting of two polynomials. And I'm pretty sure we have got some examples, some more examples regarding to adding and subtracting. So, wait. Okay. So we have two more examples. Let's just do that. Come on, yeah. In order to make it more clear and understandable, let me just check the video. Still it's going on. Yes, almost 28 minutes. So 7x cubed minus 3x squared minus 8x plus 2 minus 3x squared plus 6x plus 6. There is minus. So for that one, we need to turn it to positive. Let's just do it. This negative will become positive by multiplying this negative by each term inside the second one. Okay, we write the first bracket, 7x cubed minus 3x squared minus 8x plus 2. That negative will become plus. Okay, by what? Multiplying next negative by this positive, so negative 3x squared, negative times positive, negative 6x, negative times positive 6, negative 6. Okay, so let's just do it. 7x cubed minus 3, okay, we don't have any x cubed over there, so we write it, 7x cubed. And then finally we have negative 3x squared plus negative 3x squared, so together, negative 3x squared minus 3x squared, so add them, but still keep the negative sign, negative 6x squared. I hope that you understand this, like add them, keep the negative sign. And then finally, we have, I think there is something wrong. Okay, so negative 8x, we have it actually, negative 8x, negative 6x, negative 14x, to minus 6, it's equal to negative 4. Okay, so it's negative 4, and I think it's definitely clear. So look, 7x cubed, no friend for this one. Negative 3x squared with negative 3x squared together, negative 6x squared, negative 8x with negative 6x, negative 14x, 2 minus 6, negative 4. And it's already in standard form, fortunately. Perfect. The next one is an addition. For addition, we are happy because it's easier to deal with addition than subtraction. Okay, negative 2x5. Do we have an x5 here? Yes. 3x5. So it's just like 3 minus 2, only 1. So x5 will remain, 1x5. Negative 6x squared, positive 2x squared. So negative 6 plus 2, negative 4x squared. Okay, because negative 6 and positive 2, negative 6 then will stay, will remain. 3x minus x, 2x. Negative 1, negative 1, negative 2 when you add them, be careful. So negative 1 and negative 1, when you add them, it's equal to negative 2. It's already in standard form from the highest exponent to the lowest exponent. And that's all about adding and subtracting the polynomials. There is only one thing, like one more topic left from this lesson, which is equality of two polynomials. Okay, when two polynomials are going to be equal. Okay, when we say equal, so it means we have got two sides from your side, so it's right side and left side. Okay, so left side and right side must be the same in terms of the variable, in terms of the coefficient of the like terms, and in terms of the exponent as well. So let's just see what we have for equality of two polynomials. If two polynomials are supposed to be equal, then the coefficient, that is very important, the coefficient of each like term from left side must be the same with the coefficient of that like term from the right side. So when I just explain this lesson to the students, so this just confuse them. So you need to you don't need to write this one. It's the mathematical definition of equalizing two polynomials. Like look, when this left side is the same with the right side, so the coefficient of each like term must be the same. So for example, x powered by n, x powered by n. So their coefficients are a n and b sub n, so they must be the same. Alright, and for this one as well. For the here, x powered by n minus 1, x powered by n minus 1. So their coefficient must be the same. Sorry. A sub n minus 1 must be the same with b sub n minus 1. And finally, the constant term. The constant term here is a0 and here is b0. So they must be the same. When every single coefficient of the like terms were the same, we're going to say that these two polynomials are equal. So let's see some examples, see whether we have it. Absolutely, this is the type of question. It says, what are the values of A, B, C, and D equal the coefficients of the corresponding variables? Perfect. Forget about the second part. It says, what are the values of A, B, C, and D? So we said that right now, we need to find the like terms from left and right side. And we need to see whether the coefficients are the same or not. We need to equalize them, okay? Because since there is an equal, so we should compare them and find the unknown letters that the question asks to find it, like A, B, and C, D. Alright, here we have got 5x cubed. 5x cubed. And 1x cubed here. So together, that's going to make 6x cubed equals to. From the right side, what do we have in terms of x cubed? We have dx cubed. So simply, you're going to say that, okay, x cubes are going to cancel each other. What will remain? D equals to 6. That is the value of d we found. Okay? That is the first one. How about the next one? So it's equal to, it's the coefficient of x squared. So ax squared. Do we have x squared here? No. So ax squared. Ax squared. How about from the right side? What do we have in terms of x squared? We have got 4x squared. So x squares are going to cancel each other. And what will remain? A equals to 4. That is the value of a as well. Okay? When two polynomials are equal, this is how we are going to find out the values of unknown letters or unknown variables. Okay. The next one is x. So we have got x here, and we have negative bx here. So let's just add them. X minus bx equals to, from the right side we have got negative 4x. So x's are going to cancel each other. Alright? Remember there is a 1 here, coefficient of 1. Some of the students are just doing like this. When they cancel x, they feel like there is nothing over there. But in fact, there is a 1. So cancel the x's and see 1 minus b equals to negative 4. Okay? Move this one to the other side. It's going to become negative 1. And then finally, negative b equals to negative 5. And the negatives are going to kill each other. So b equals to 5. That is b as well. So we found d. We found a. And that is b. Okay. And then finally, let's just find the final letter, which is, I guess, C. Okay, the C is the constant one, the constant term, because there is no x with it. So negative 2, the constant number, the constant term here is negative 2, plus C equals to, from the right side we have got 6. So simply move this negative 2 to the other side, it's going to become positive 2. And finally we have C equals to 6 plus 2, 8. That is how you are going to find out the values of some unknown letters, some unknown terms, some variables when two polynomials are equal. Okay. If you did not understand it, either review the video or listen to me for this one carefully in order to catch it. Okay. So x cubed, 3x cubed. Together, that's going to become 4x cubed. Okay, from the left side. And from the right side, what we have? dx cubed. So x cubes are going to kill each other. And finally, d equals to 4. That is d, simply. Okay? How about the x squared? So we have got bx squared. We have any x squared here? No. And from the right side, we have got 2x squared. So x squares are going to kill each other and b equals to 2. Right? Okay, of course it's right. So we have 2x here, 2x plus 1x, 3x. From the other side we have got negative ax. X's are going to kill each other, so 3 equals to negative a. But remember, we are not looking for negative a. We are looking for positive a. So a equals to negative 3. Alright, that is a as well. So a, b, c. It's not c, c left. We have no constant term here. We have got c over there. So simply c equals to, the constant term from the right side is 3. That's it. So c equals to 3. And I hope that right now it's clear. Any more questions? Let's see. Yes, we have got it. Page 16. What are the values of a, b, c, d equal the coefficients of the corresponding variables? Okay. So here in part A we have got 4x cubed and bx cubed. So from the right side we have got negative 2x cubed. So let's just equalize these coefficients of these corresponding variables. So 4x cubed plus bx cubed equals to negative 2x cubed. Okay, so x cubes are going to kill each other. I need it over here. that x cubed is x cubed is x cubed. What will remain? 4 plus b equals to negative 2. Move this 4 to the outside, it's going to become negative 4. So finally b equals to negative 6. That is b. Okay. How about x squared? So we have negative ax squared here, and we have got positive 2x squared over there. And then from the right side, we have got negative 3x squared. So x squares are going to kill each other. What will remain? Negative a plus 2 equals to negative 3. Move these two to the other side, it's going to become negative. So negative a equals to negative 5. And then the negatives will cancel each other because we are looking for a, not negative a. So a would be basically 5. Okay? So a should be 5. Perfect. How about here? X minus dx. X minus dx. What is the corresponding variable here? So it's x, so the coefficient of x is negative 4x. X's are going to go with each other. Again, remember there is a 1 here. So 1 minus d equals to negative 4. Move 1 to the other side, it's going to become negative 1. So negative d equals to negative 5. Negatives are going to kill each other because we are looking for positive d, not negative d. So d equals to 5. That is about the story of d. So right now we have b, a, d. And finally c, we have got negative c over there, plus no constant term here, so equals to positive 9. So we are not looking for negative c, that's why c would become, this negative will go here, it's going to become negative 9. C equals to negative 9. Alright. And then finally in the second question, we have only one unknown variable, which is b. So let's just do it here. Here the coefficient, the coefficient of x squared here is b. So bx squared. And from the right side, it's negative 9x squared. So x squares are going to cancel each other. What will remain? B equals to negative 9. That's it. So b equals to negative 9. Ladies and gentlemen, and dear audience, I hope that you understood this lesson. And I hope that these videos are beneficial and for you. And you get benefits, a lot of benefit from it. And that's it. That's the end of the first lesson of chapter 2. I guess no other topics, no other slides left. Let's see. Yeah. So nothing left. In order to see you in another video, take care of yourself. And thank you so much for listening to me. And try to study hard and prepare yourself. Take notes. Take care. Goodbye.